Siemens factory in Kalwa, India manufactures switching cabinets for distributing power in infrastructure and industrial grids. The switching cabinets are produced in different variations to customer demands, mostly for the domestic Indian market, the Middle East, and other Asian countries. About 100 components are built in during assembly.
In fiscal year 2008, Medium Voltage decided to make a worldwide rollout of the Siemens production system. Besides Turkey, Portugal, Mexico and China, India was one of the first locations where we started the implementation of the Siemens production system. And Kalwa here is a very good example for the implementation in an emerging region. And based on the excellent results which has been achieved, CSP has chosen Kalwa as best practice and a seed to start a rollout in further location in this region.
The old production line was organized along the construction site principle. All components were assembled at a fixed position. That is why preparations before the actual assembly took up too much time. Space often had to be cleared for preparing materials for assembly. Tools were often not where they were supposed to be and had to be tediously searched for. Because there was no standardized assembly sequence, this often had to be tediously worked out by the employees for each order. That led to a lot of discussion. An unfavorable material feed and missing support thus demanded the simultaneous attention of several employees for even the easiest of assembly steps. Consequently, processing times for assembling a finished product considerably varied, and the stocks in half-finished and finished products gained previously unthought-of proportions. Something had to change. The process steps could be clearly optimized by applying the Siemens production system philosophy, because the Siemens production system supports putting lean thought into practice in production. That is, waste are consequently eliminated.
Change was essential in switchboard Kalwa processes to improve productivity and profitability from operations. We were convinced that implementation of Siemens production system is the right step to achieve this.
Following the lean principle, production was reorganized into flow production according to the one-piece flow process principle. Now, the switching cabinets are assembled step by step in specialized workplaces according to a predetermined tact rate. A clear signal symbolizes tact completion of any given production step. The employees have all the necessary materials and tools required for their assembly step on hand. The high job repetition rate protects against errors creeping in. Production process problems are sent via a red signal to the group leader and can be jointly corrected with him. Logistics were also optimized.
This is a good example of two-bin system and Kanban implemented here, where we have implemented the FIFO system, which benefits an operator to get the material at his job and also a continuous material supply as per the tact.
The understandable supply of material containers at specifically defined places gives employees more confidence about having assembled all the essential parts. Color marking the containers additionally ensures that the materials always reach the right places, blue to blue and green to green. An employee in production control fills out a standard production card which lists the components to be commissioned for the corresponding customer order. He attaches this production card to a special board in its order of assembly processing. The warehouse employee picks up the cards in their given order and puts the corresponding materials together. The card goes back onto a second board to the colleagues in production management. That assures the order has been placed and really started into assembly. floor markings for larger components also inform everybody if enough material is available. The red fields here show that component supplies are running low and refills are urgent. You'll notice that everything has its assigned place. Every component stands on the field assigned to it. Order and neatness increase transparency. Consequent application of the Siemens production system methods and the essential discipline impressively raised the efficiency of final assembly. But the improvements did not stop here. Let's take a look at what happened on the breaker line. Production in the exit state was also organized according to the construction site principle. With the already known problems, tedious workplace preparation, searching for components, unclear job step orders, and searching for tools. Again, they resulted in strongly varying processing times for every breaker. And again, applying the Siemens production system methods in the new breaker line permanently raised the assembly process efficiencies. The one-piece flow concept was also consequently applied in panel assembly. Every product is continuously worked on up to its finished assembly. Buffer zones with half-complete products, overproduction, and batch lot buildup are eliminated. Workplace ergonomics are considerably improved. Each station's job contents are oriented to the tact rate. The product continuously flows through assembly. The employees have both the materials and tools clearly at hand and can thus concentrate on the most important thing, creating value. Problems are immediately discovered and the responsible engineers are notified so they can immediately solve the problem on the assembly spot and define measures for a lasting avoidance of the problem ever cropping up again. And things can continue, production in flow. The pull principle is consequently applied. That is, the respective next station dictates the tact rate and pulls the components through assembly. This avoids overruns. A station can only produce that which the follow-up station needs. The final testing shown here reveals the effectiveness of lean methods. The number of faulty products has clearly dropped because far fewer errors creep into production.
Lean promotes the philosophy of built-in quality over test-in quality. This has resulted in an improvement of 40% in the first pass yield.
We can see a lot has happened in Kalwa. The employees' work has been simplified and clarified. Productivity has gone up, and product quality has also considerably improved.
We could improve production output per blue collar by 40% and reduce our production lead time by 30% during short time. To be successful in coming years, lean principle and following lean steps is going to be a key factor.
The most important thing is that change begins to happen.